Okay, so we're looking at the HMDA Boston Fed dataset for the Monell et al. 1996 paper. We've loaded in already the varying libraries, so the ECDAT package, the Tidyverse package and party. We've also looked at the what's in the HMDA dataset, and that's available here in the help menu that you can pull up just by putting a question mark in front of the dataset that we're going to use, which has 2,381 observations of 13 variables. So these are 13 predictors for a 1990 dataset that are used to predict was a mortgage application denied or not, and that can be examined down here. Now the definitions are also available here in the script, and I will copy this code and put it on the RStudio cloud and machine learning portal. So that's in the Google Sites, and I'll leave that link below this video as well. So we go back into RStudio Cloud, which is based in the browser, and whatever we save here then remains. Now, might be no harm. First thing we might do here, which is of some practical relevance, is just save this and give the file a name, and we will refer to it as HMDA, and I think I'll call it Tidyverse. Okay, so Tidyverse. And this is for exploratory data analysis, right? So that red area untitled now has changed to HMDA, and if we look at the files, we should see that file now has appeared here. It wasn't there before. Okay, so that's something that's new. And okay, if we want to examine the data, just look at the headings. We get the first 6 rows, and we have here 13 variables. I think we have debt servicing to income ratio, household expenses to income ratio, loan to value ratio, credit score, mortgage credit score, public record of a bad debt, denied mortgage insurance or not, so that's a binary variable. Likewise, this is also binary. Self-employed or not, so no, it would mean employed. An employee. Single, are you single? So in most cases it would appear couples. Unemployment rate in the relevant occupational sector of the applicant. And you can see we've managed, because of this little snippet of code here introduced by Halvarian, we've converted we've changed the 11th variable in our data set from condominium, the original entry, to condo. So that change has been made. Good. And we have if the individual is African American or not, and then deny this is what we want to predict. Did the individual manage to succeed in getting their mortgage? So deny no is actually positive. Yes, they got their mortgage. So keep that in mind. Deny no means successful in getting the mortgage. We can do a summary, and that will bring out different medians, mean, first quartile, third quartile, the maximum. We can look here at the credit score. It ranges from a minimum of 1 to a maximum of 6. The median value, so the typical value would be 1, but the mean would be 2. And for mortgage credit score, the mean is 1.72, but the median is 2. The number of African Americans is 339, out of, with their balance being 2,042, who we might refer to as being white. Deny means here, did you succeed in getting the mortgage? So deny no means successfully obtained the mortgage. Deny yes means you weren't successful in getting processing the mortgage application. So the vast bulk of applicants do seem to be successful in getting their mortgage. Now, in the Monell 1996 paper, they provide evidence that for the Boston metropolitan area, in 1990, 28% of black applicants were unsuccessful, whereas 10% of white applicants were successful. And that seems to suggest at first glance that there's some kind of prejudice or some type of discrimination taking place. What Manel and Al 1996 went on to do was try to introduce these other variables, non-HMDA data, where they looked at they went directly to the banks and they requested this data at some cost to themselves, some cost to the Federal Reserve of Boston, and they obtained this other data relating to the credit risk of the individual, and then tried to use these as controls and then examine the extent to which African American applicants were treated differently to white American applicants. Okay, so we can have a look at the data here, the structure. We can see what's considered number and factors, and that looks fine. And then to bring it up in the RStudio viewer, we can look at these variables, and of course we can see there are 2,381 observations. Okay, so everything looks fine. First thing we might do then, just to make use of this, the Tidyverse suite, we would like to visualize a little bit our data. So just look at the numbers, the relative numbers of deny and accepted. So if we run that, what we find here is the vast bulk of individuals, their mortgage is accepted. So deny, no, means your application was successful, and a smaller proportion, much smaller proportion, are successful in applying for their mortgage. We can then break that down, look at the credit scores, and again, the vast bulk of individuals have a credit score of 1. In fact, that's the top credit score, and then 6 is the lowest credit score, and that seems to taper off a bit and then go up a little bit for categories 5 and 6. But these are the worst categories, and 1 and 2 would be the best. Likewise, for mortgage credit scores, there's 4. So it ranges in 1 to 4, and the median value here obviously is 2. So most people have a mortgage credit score of 2. So this the mortgage credit score is like the credit score, the CCS, except it relates to were there slow payments on the mortgage or not. Has the mortgage been paid in time? So this monitors that, but it could be a factor. We would like to examine that. Okay, ggplot, again, some more visualization. This time we're going to look at the extent to which the mortgages were denied for different credit scores. And we had 6 credit scores, but we also seem to have this unusual number here, and that's a bit problematic. We shouldn't have a credit score of 2.11, so there's something awry, and we will correct for that, and we will create a new data set where we change, we just filter out the complete cases and exclude from our data set incomplete cases where NA might appear. Let's run that line of script, see what occurs, and we might just see what we've got here. And you can see now all is, well, we're just 1 less than the original data HDMA. Now we have 2,380, and we just excluded 1 row. Okay, so that's okay. And we've cleaned up our data set. So we'll rerun, again, if you like, we will rerun this snippet of code 1 more time. And we'll use, instead of using HDMA as our data set, we'll use all. That just excludes 1 where there's incomplete data. And when we run that, we can see 3, we go 1, 2, 3, 4, 5, 6, and that's as we might expect. Those that have the highest, the best credit score, so a credit score of 1, the vast bulk of those actually are successful in obtaining the mortgage. Whereas when we get up to a credit score of 6, there is less of a discrepancy in terms of relative numbers succeeding getting their mortgage and failing getting their mortgage. So it would appear at first glance the better the credit score, the more likely you are to succeed in getting mortgage. So that would suggest that CCS, the credit score, is an important variable here, or one that we would need to address. So some more analysis here using ggplot. Now, we've taken exactly the same couple of lines of code, but we make one small change. Just after deny, we include this syntax with fill, and that's a variable public record of bad debt. So there may be some court finding against an individual for non-payment of a debt. If so, that was a variable. You can see that for a credit score of 6, quite a few of those had those records that would have been disadvantageous in terms of making the application. Not so prominent here if you had that PBCR finding against you. If that was, it doesn't seem, if you have a credit score of 1, to be that as important. Doesn't exclude you, but if your credit score is 6, then having a PBCR does seem to be a factor. So this is one of the initial observations we can make here. These variables interact. One, a variable or a finding, a public record of bad debt is not a hanging offence, but if also if we throw into the mix you have a low credit score, then the two together seem to conflate, right? And can be problematic then for the individual making an application. We do the same, but this time we look at DMI. DMI is denied mortgage insurance. Mortgage insurance could be important if you wanted to, if your mortgage was to be sold onto secondary markets. So in the United States you have a lot of securitization and mortgages get sold on into secondary market. There's a conventional market, there's FHA, and there's VA. In conventional resale of mortgages, if your LVR, if your loan to value is quite high, they may insist on this. So this could be very important. Let's take a look. If you have a credit score, so at first observation, if you have a credit score of 1, which is the best, but you were denied mortgage insurance, yes, you can see here there's quite some evidence to suggest that weighs against you then in terms of getting a mortgage application. So looks to be important. That given the shallowness of the blue here, we would also suspect it's not the numbers who were denied mortgage insurance were quite small, but we'll take a look at those in a moment, actual numbers. We now look at self-employed, and so on the x-axis we have self-employed or not, and then on the y we would have the numbers involved. So the vast bulk of people are not self-employed, and roughly maybe less than 10% or a bit over 10% are self-employed. And we can do the same again, except in this instance now address the code that we had before, but instead of putting in DMI or putting in PBCR, we could actually put in self-employed to see perhaps maybe if you're self-employed, perhaps there is some risk to your earnings, stability of earnings. And at first glance here, what we would observe, there is no immediate evidence to suggest that individuals who are self-employed are somehow at a disadvantage when applying for their mortgage. That's what we might observe. We might do more thorough analysis later on in this, but that's the first impressions that we get in this exploratory data analysis. In the next video I'll continue.